Hi guys, how we doing? Welcome back to another video. So I'm still going through this HP2001 product from Matrix, which is a brushless DC motor drivers coupling pair. So you got a brush motor and a brushless motor, and then I can either drive the brush motor with the brushless, or I can drive the brushless with the brushed. Yeah, and then I've got like a microcontroller here which can control things and that sort of stuff. So in the last video we kind of figured out how alternator works, how a car alternator works. Which I'm getting there. I'm getting better. And so now this is quite an interesting one. So worksheet 16 is fault finding in charging systems, which is crazy because I think I might have a fault with my wife's car. So it's a bit mad really how like this particular worksheet might actually help me diagnose a problem with my own car, that's nuts. Anyway, so let's just whiz through this fault finding. So it's just literally just two worksheets? 2 pages, yeah. So just 2 pages. It uses the same layout that we had in the last video, but I'll just quickly whiz through it. So we've got our 12-volt power supply coming in here. That then feeds and powers this microcontroller, which we used to have a potentiometer here on the input of this microcontroller, but instead we've now just got a standard voltage divider, 1K resistor, 2.2K resistor. Got a MOSFET driver on the output of this microcontroller, and this MOSFET driver is driving this brushed DC motor with a flyback diode there. And then we've got a rectifier, a four-way rectifier circuit going on here, and then that's rectifying this brushed motor is driving and producing a three-phase signal on the output here of this brushed DC motor, and then that three-phase signal is getting rectified into a DC signal, and then we can detect that across this 1K load here with a smoothing capacitor. That's the circuit that we have. We've also got some, I believe these are load resistors, which are used in giving feedback to balance the alternator. So being good at fault finding is about being systematic. Understand the fault, gather information, formulate a theory and test it, repair and retest the circuit. That's probably true for every fault diagnosing for an electrician. This investigation uses the same circuit as that in the second part of the worksheet 15. It maintains a voltage of around 1.5 volts at the system output across the 1K load, which is down here, regardless to an extent of the load on the system. Build the circuit shown on the next page, but initially without the 3 links which are colored orange. So that's these 3. So let's take these out. Cool. So we've done that. Set up a multimeter to measure the voltage across the 1K load. Okay. Got my meter. Bob that there, and then let's measure the voltage across our 1K. So we've got a fluctuating 1.5-ish volts, but it's not steady. And then we saw that in the last video. As we add links, it became more steady. Set up the DC current clamp to read DC currents up to 2 amps and position it to measure the current delivered to the DC motor. I haven't used this bad boy in a while, or I don't think I've used it since I bought it. So we can get rid of these and then just stick this onto current. 200 amps, 2 amps. Okay, so set up the DC current clamp to read DC currents up to 2 amps and position it to measure the current delivered to the DC motor. So what is considered the DC motor? That is this brushed one, yeah? So if we clamp that on there, it's on AC. How do I get it off AC? Does it matter? Okay, yeah, it should be on AC, right? So I've got like no current. 0.0, what's that, 50 milliamps. Position it to, okay. Measure the load voltage across the 1K resistor. So it wants me to record this. So we've got 1.5 volts and 50 milliamps, which I'm not gonna record, but if one of you guys could just remember that for me, yeah. So 50 milliamps, 1.5 fluctuating volts. Add the first left-hand orange link, so that's this one. So now we get 1.7, fluctuating between 1.3 and 1.7 volts, and we've now got 70 milliamps of current instead of 50. So that's giving us more current. Second, what do we get? We get a more stable 1.6, 1.7, and we've now got 80 milliamps, kind of fluctuating a bit. You can even hear the motors fluctuating a bit. And then the third, so that pushes us, that's a stable 85 milliamps and 1.7 volts. Okay, record all your measurements. Yep. Remove one of the rectifier diodes to simulate a partial fault. So this is interesting. So if we remove a rectifier diode, what do we get? Our voltage has just dropped to 1.3. Our current has stayed the same. Okay, repeat the measurement and record them in the second handout. Oh, okay, that was. So does it want me to take out all of them? So we're now at 47 milliamps. Oh wow, that's going a bit more crazy actually. Ah, interesting. So what is it? Is it trying to say that if, because that's fluctuating between 50 milliamps and 80 milliamps, so it's trying to say that if you had a fault on your rectifier circuit, you would just be getting wild readings? Is that? So that's still stable now, ish. 80 to 86 is fluctuating. Okay, I'm not sure what I'm supposed to be learning here. Remove another rectifier diode and do the same thing. I'm not sure what I'm. So the voltage is even worse in fluctuation, which you would expect, and the current is stable high. Like, what is that current? 85 milliamps. So voltage is very low now, 0.8, but current is 30. Okay. Now on to the second question. All right. So that's the end of worksheet 16. There's some questions in the student handout. Let's see. I haven't actually looked at the student handout since doing these videos. But so worksheet 16. I did say this in the other video. Let's just turn it off. I said this in the other video that because obviously this is meant to be taught with a teacher, I could see how if I had a teacher here explaining this to me, I could learn a lot. But I'm not actually sure. Like, I can see some differences, sure, but I don't know. I don't really know what I was meant to learn there. All right, so what happens to the drive percentage shown on the ECU display and the DC motor speed as extra load is added? Worksheet 16. Oh no, what was I just doing? Worksheet 17. Okay. No, I don't know. What worksheet was I just doing? I was doing worksheet 16, yeah. So it just said in the student handout, worksheet 16. Worksheet 16. What happens to the drive percentage shown on the ECU display and the DC motor speed as extra load is added? Okay, I didn't see that. I didn't actually look. It didn't tell me to look at that display, so I didn't look at any of that. With one diode removed, output voltage, output current, with two diodes removed, how is the performance of the system affected by faulty diodes? So again, and even there, unless there's some answers at the end, notes for instructor. Okay. Let's go to worksheet 16. No readings or unexpected readings on multimeter clamp. See multimeter checks. Okay. Point for discussion. Discuss the effects of diode failure. Yeah, so I don't really understand what I'm looking at there. So, all right. Well, we'll call that quits. I'm not sure what I was meant to learn really from that video. Kind of was just, or from that worksheet, it was kind of just the same as the previous one really. Same circuit. I guess I got to use my current clamp, but yeah. Cool. All right, anyways, thanks for watching, guys. I'll see you in the next one. I think we've got, what is it? Worksheet 16 was what we just did. Does worksheet 17 use this DC motor coupling thingy? See if I can just get there. Worksheet 17, generating a higher tension, does not use this motor, so we won't be going in there. And worksheet 18, fault finding high tension systems, and again, it doesn't use it. So that's the end then of that one in terms of that schematic or that curriculum. But if we go onto the Matrix website and if we search HP2001, this is the name of this there. Okay, so we've got that. So I've essentially finished this curriculum now as it pertains to this. So now I'll be starting on this one here, which is batteries and high voltage systems, and I've got this kit next to me on the floor. So yeah, in the next video we'll start with this curriculum and then we'll just go through it and see what changes need to be made. Oh, curriculum, nothing. Resources, nothing. Damn. Okay, I'll have to try and find that. There's going to be a curriculum for that. So those are lithium ion and lead acid batteries in that steel case. So that should be fun. We get to play some batteries. Cool. All right, thanks for watching, guys. I'll see you next one. Take care. Bye bye.